Hello. Welcome to Circuit Lab. In the last example, what we went through was electromagnetism, where we put a coil around a iron core, which resulted in formation of and we found out that the compasses on both sides essentially moved, which showed that the magnetism and electricity were tightly related. Okay, so today what we're going to try and find out is direction. All right, we're going to find out the direction of these fields. Okay, direction. So the entire component today is going to be to understand how do we figure out what is the direction of these magnetic fields. Okay, so the first thing we're going to learn about, quite honestly, is how do we figure out if there is an electric current that's flowing. Okay, how is that um, um, it, how is the current moving? Okay, so in this example, we're going to take a simple wire that has current that's moving in this direction. Okay, so the wire is there, and then let's assume that there is a positive here and a negative here. Okay, so the current is moving in this direction. What we want to find out is how exactly is the magnetic field moving in that direction. Okay, so quite simply put, we're going to understand the concept, okay, of a right hand rule. Okay, what the right hand rule specifically states is um, that if you hold on to a wire with your hand and your thumb is pointing towards the direction of the current, the way your fingers are moving will give you a direction of the magnetic field. Okay, so let's take an example. In this example right here, um, in this scenario, if the current is moving there, okay, your thumb is going to point this way, so your thumb will point up. Okay, so imagine you're grabbing onto the wire, your thumb is pointing up, and your fingers are going to curl this way. Okay, that means this is the direction of the magnetic field. The direction of the magnetic field is going to anti-clockwise. Okay, so just pretend you're going to hold onto your hand, your fingers are going to curl in an anti-clockwise direction. Okay, now hopefully that helps you guys understand how to figure out the direction of the magnetic field. Okay, now let's go into something a little bit more complex. We're going to look at an iron core now. Okay, a super magnet, and see how that would behave in terms of their magnetic fields. Okay, so earlier we used an example of a iron bar. So this is our iron bar, and we essentially took that bar and we put some coil around it. Okay, and the reason why we put a coil around it is we want to have a multiplicative effect of the magnetic field. So we're going to connect it to a battery source. This is positive, this is negative. Okay, now one of the questions comes in, okay, is this right here a north pole or a south pole? I don't know. Okay, so let's figure this out. The way to figure this out, first and foremost, would be to figure out the direction of the current. So we know the direction of the current will go from positive to negative. Okay, you're going to then go ahead and trace down right in front of the iron core. There is these wires right here. Okay, so let me just explain to you. You see these wires right here in front? Okay, what direction is a current moving right in front of the core? Okay, so you're going to look at that. Now, it's very easy to trace, okay? And the reason why it's very easy to trace is that each of these wires are moving um, in a direction that is quite simply the current goes up, it goes down, goes down, goes down, goes down, goes down, and then continues on its way down. So all you're doing is you're tracing the path of the current, all right? So the first step that we do is that we figure out which direction the current is moving in the coil, okay? The next step, what we need to think about is you're going to pretend you're going to grab onto this wire. So here we go. Let's just take this wire. You're going to grab onto this wire. But remember, your thumb is going to point down, okay? Your thumb is going to point down. Okay, your thumb is going to point down. So imagine you're going to grab hold of this wire, the green arrow, your thumb is going to point down, and your fingers are going to point this way, right? So they're going to point, they're going to circle this way. Okay, your fingers are going to curl. When you hold the wire down, your fingers are going to curl this way, all right? That means they're going to be pointing towards this direction. Okay. So if your fingers are pointing that direction, that means the arrows are pointing out. If the arrows are pointing out, then we know that this is the North Pole and this is the South Pole. Okay, so hopefully this gives you guys a quick sense of how do we figure out, in a coil, whether it is which side is a North Pole, which side is a South Pole. So this gives you just one example of it. Now we'll take another example, which I think may be interesting to you guys, but done in a different way. Okay, so let's just go through that real quick. Okay, so we're gonna again do the same thing. We can actually do two separate things. Um, okay, this is one example. That's one. And then this is two. Okay. And then in one example, the wire comes in. Okay, this is positive and this is negative. The other one is it goes behind. Let me just erase this out here. Okay, so now our goal is to figure out, okay, which direction is a magnetic field, which side is a North Pole, which side is South Pole. So first, let's make sure that we indicate where the current is flowing. So current is flowing from positive to negative. Okay, it's going this way. It goes down, comes back this way up, this way up, this way up. Okay. Similarly, current is flowing positive to negative. So current is flowing down, 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 down. Okay. Now, remember, in this particular example, we're going to use the right hand rule. So let's take this wire here. Actually, let me just use a different color. So let's use a purple color. So we're going to take this guy here and we're going to right hand rule. So thumb is going to point up. That's your thumb. And the fingers are going to curl this way. That means the magnetic field that we are looking at is going this way right here. Okay. All right. So there it's curling out this way. Okay. 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 Similarly, now let's look at the other example. Now in this one example, when we were to, let's grab hold of this wire right here. Your thumb is pointing down. If your thumb is pointing down, your fingers are curling this way. Okay. If the fingers are curling this way, that means the magnetic field is in essence going this way right here. And remember, any point in time arrows are pointing out, then we know where the poles are. Okay, so let's actually identify where the poles are here. Okay, so since in this case the arrows are pointing out, this is the North Pole. Since in this case the arrows are pointing out, this is the North Pole. All right, so now think about this way, just the way the coils have been put together clearly influences the direction of the North Pole and also the South Pole. So I hope this video is helpful. Remember, your best friend here at this moment in time is going to be your right hand rule. And there are three simple steps. Trace the current, that's number one. Number two, identify the wire right in the front of the iron rod. Point your thumb in the direction of the current. Roll your fingers. Okay, roll your fingers, and the direction in terms of your fingers are rolling is a direction of the magnetic field, and whichever sides has arrows that are leaving or they're moving out is the North Pole. The one side that is receiving the arrows in is the South Pole. So I hope this is helpful to you to figure out which direction the magnetic fields are moving. Thank you and goodbye.